Okay. So, uh, thank you for coming. I-review natin yung ginawa natin kahapon. So, kahapon i-introduce sa inyo yung um, uh, quantum computing and how quantum computers work. And nirelate natin to sa kung paano nag-work yung classical computers. Okay. And then nakita natin na in comparison sa classical computers, quantum computers can have several states, okay? Not just yung on-off state dun sa classical computer. Okay, and sa classical computer, the way to implement yung on-off states is by use of transistors, at yung transistors na yun ay binubuo into classical gates, okay, and or XOR and so on and so forth. Okay, and then sinabi din natin kahapon na yung quantum gates, yung quantum computer na gumagamit ng quantum bits or qubit, okay, ay tawag dito, nagre-rely din sa mga tinatawag na quantum gates. Okay? At yun yung pag-aaralan natin today. Ano itong mga quantum gates, okay, na ginagamit ng quantum computer. Okay? So from the quantum gates, you can create itong mga processes. Okay, of course, we don't use quantum computers just to simply add numbers or do simple mathematical operations, but instead, we use them for more complex operations such as sa cybersecurity, sa image processing, tawag dito medical applications, okay, and so on and so forth. So yun yung mga tawag dito. Gusto natin gamitin ng quantum computers kung saan na pag ginamit mo yung process sa classical computers, matagal yung process. So ang gagawin natin is i-reduce natin yung processing time with the use of quantum computers. Okay, so ang isang example na niyan is yung classical na cybersecurity methods. Okay, ang ginagamit na cybersecurity method ngayon is tinatawag na RSA and relies on the computation of prime numbers. And pagdating sa quantum computers, okay, it's actually exponentially faster. Okay, yung pag-compute ng prime numbers, and that's why it's easier to hack classical computers using quantum computation methods. Okay? And yun yung mga pinag-aaralan ngayon. Well, not just hacking, but yung opposite side, which is to prevent hacking. So yun yung tinatawag na quantum resistant technologies. And to be able to learn that, dito tayo magsa-start sa mathematics. Okay, sa simple mathematics ng quantum computing. So, yan. So, dinescribe natin yung quantum bit, okay, which is the smallest, tawag dito, unit na nagagamitin natin sa quantum computer as this. Diba? Ang state of a qubit, it's a quantum mechanical state, is described by this wave function, okay, psi. So, gamit lang ng ibang kulay. So itong wave function na psi. Okay. And yung wave function na yan, tulad ng sinabi natin kahapon, is composed of a superposition of states. Yun nga yung kinaganda nung quantum computers. Kasi we can use, for example, two states, ket 0 at saka ket 1. Okay. And we can use them simultaneously. We can do parallel processing with this single qubit. Okay. Now, this single qubit, o itong mga states na ito, tinatawag natin basis states, yung ket 0 at ket 1, okay, ay merong amplitudes. Okay, so ito yung mga amplitudes nila. Okay, alpha and beta. So alpha corresponds to the amplitude of ket 0 and beta corresponds to the amplitude of ket 1. Okay, and then ito naman yung mga basis states na dinescribe, ibang basis states na dinescribe natin kahapon. So we have yung Hadamard basis, yung Y basis, Bell basis na yan, pag-usapan natin mamaya or bukas, and Fourier basis. Now, to be able to use itong mga basis states na to, we need to convert them into some mathematical form. And yung mathematical form na yan, okay, ay in terms of matrices. So for example, yung ket 0 na state is described as a column matrix na may two elements. Yung first element ay 1, okay, at yung second element ay 0. Tapos yung ket1 is described as a column matrix na yung first element ay 0 and yung second element ay 1. Okay, so yan na yung gagamitin natin na definition ng standard basis nito. So this means that we can also write itong wave function, itong ket psi, okay, as a column matrix. And to do that, we re-express itong ating equation. So ito i-re-express natin as a column function. At ito express din natin as a column function. Okay, and then multiply natin yung alpha dun sa anong tawag dito dun sa column matrix. Ito yung lalabas. And then we add these two column matrices to get this. So ito ngayon yung matrix representation nung wave function na psi. Okay, so and makikita natin na yung alpha and beta, which are yung amplitudes, okay, yan yung elements nung column matrix that represents yung ket na psi. Okay, now, ang isa sa mga peculiarities ng quantum physics is that itong states na ito, ket 0 at ket 1, for example, they exist simultaneously only if you don't make a measurement. But once you make a measurement, okay, yung state na yan collapses. Okay, it collapses to ket 0 or ket 1 depending on yung probability. So ang example na ginamit natin kahapon is yung toss coin. So yung probability na makakuha ka ng heads tsaka tails ay 50-50, right? So every time you toss a coin, okay, there's a 50% chance that you get a heads. You get heads and 50% chance that you get tails. And ganun din dito. Every time you make a measurement, okay, there is this probability that you will get ket 0, or there's this probability that you will get ket 1. Okay, so yung probability for ket 0 is alpha squared modulus squared, which is defined as alpha star alpha. And yung probability for beta squared is defined as beta star beta. Okay, and dapat yung total probability na yan must be equal to 1. So alpha squared modulus alpha squared plus modulus beta squared ay dapat equal sa 1. And then finally, towards the end kahapon, okay, dinescribe natin ano ba tong ket na ito, yung notation na yan. Okay, so it's actually yung full notation niya is actually called a bracket notation or Dirac notation after Dirac, na kung saan siya yung nag-develop ng notation na yan. Okay, and it's a very convenient notation kasi we represent nga ang mga states na to into as matrices. So for example, ang ket is represented as a column matrix at ang bra is represented as a row matrix. Makikita natin kung gaano siya ka-convenient kasi if we multiply itong bra at saka yung ket, like what we did yesterday, okay, then we're essentially multiplying a row matrix by a column matrix. So row matrix by a column matrix. And if we do that, we get this scalar value. And yan ngayon yung tinatawag natin na inner product. To multiply bra and ket, we get actually yung inner product nung wave nung bra at saka ket na equation. Okay? So diyan tayo natapos kahapon. So let's continue. Okay? So makikita natin na each ket is associated with a bra. Okay? So we can write each ket is associated, okay, with a bra. Okay? Okay? At ang tawag natin dun sa association na yan, ayusin ko na yung handwriting. With a bra. At ang tawag natin sa association na yan is a joint. Okay? Or, ang isa pang tawag dyan is conjugate transpose. Or permission transpose. Okay, so ano ibig sabihin nito? Well, if I have ket 0, okay, at kinuha ko yung adjoint niya, okay, yung adjoint means, ang symbol for adjoint is this. Okay, so it's a dagger. Okay. Ang ibig sabihin niyan is you get the complex conjugate, okay, and then you get the transpose or vice versa. Okay, so it doesn't matter. Pwede mong kunin yung transpose ng matrix and then you get your complex conjugate. Okay, so when you say complex conjugate, okay, pag sinabi natin complex conjugate, okay, so what you're doing is you're replacing each imaginary number by its negative value. And pag sinabi natin transpose, okay, so we are ano ba? Tawag dito? Converting the elements, okay, with respect to its diagonal. So ibig ko sabihin ganito. Ito yung example. Magbigay ako ng example. Halimbawa, 1, 2, 3, 4. If we get yung transpose nito, so ito yung, ang tawag dito ay yung diagonal elements. So hindi natin gagalawin yung diagonal elements na yan. Pero yung 3 at saka 2, pagpapalitin natin ang position. So dito malalagay yung 3 and yan yung 2. So ang ginawa natin essentially is pinagpalit natin yung position. So we are transposing with respect to the diagonal elements. So, kung column matrix siya, like for example, 1, 0, okay, at kinuha mo yung transpose niya, magiging row matrix siya. So, magiging ganyan. Okay? So, and and we know that ket 0 is a column matrix. And if we get yung transpose niyan, okay, then this becomes a row matrix, which is essentially a graph. Okay, so bra ng 0. And then yung complex conjugate, okay, nung 0, nung ket 0 or bra 0 in this case is just itself kasi wala naman siyang imaginary na number, na value. Okay, so ito yung sinasabi dito. Each ket is associated with a bra that is its adjoint or conjugate transpose. So this ket 0 is associated with yung bra 0. Okay, so bawat ket ay merong associated na bra. And ganun din para sa ket 1. We get its adjoint, then this gives us yung bra na component. And that's easy enough to see kasi for ket 0, we have 1, 0. You get yung adjoint niyan, then you get yung row matrix. Okay, and then for ket for ket 1, kunin mo yung adjoint yan, then you get yung row matrix na 0, 1. Okay. So, if we use naman yung ket state, ket psi, okay, sinabi natin ang ket psi is alpha plus beta, alpha ket 0 plus beta ket 1. Okay, and we get yung adjoint nito. So, what we're doing is we're taking the adjoint of ket psi. Okay, and ito, kunin natin yung complex conjugate niyan. Remember that alpha and beta are amplitudes, but they can also be complex. Okay, they are complex numbers. Okay, so then kunin natin yung tawag dito. adjoint ng 0, ket 0, beta star, and then adjoint ng ket 1. Okay? Okay. So, anong mangyayari dito ngayon? Okay. Dito hindi ko na in-applyan ng transpose itong mga amplitudes kasi nga scalar sila. Okay, but they are complex. Okay, so kailangan pa rin i-apply yung complex conjugate. Okay, so ang mangyayari dito ngayon is we get psi star, and this becomes bra psi, and this alpha star. Okay, tapos this will become bra 0 plus beta star, and this will become bra 1. Okay. And if we apply yung knowledge natin about bra 0, gamitin natin yung matrix representation ng bra 0. This is 1, 0 na row matrix plus beta star. Tapos yung matrix representation naman ng bra 1, this is 0, 1. So this becomes alpha star 0 plus beta star, plus 0 beta star. Okay, and then pag in-add natin yan, we get alpha star, beta star. Okay, or alpha, beta star. Okay, so yan yung ating ket sign. Okay. Okay. So yan yung yan ang sinasabi natin dito na each ket is associated with a bra that is its adjoint. So every time na mayroon kang ket na wave function or ket na state, meron yung associated na bra na state. And you can get yung associated na bra na state by simply applying yung wave function, yung adjoint or Hermitian. Okay, so I hope clear yun. Now, pinag-usapan natin kahapon yung tinatawag na inner products. So we can generalize yung inner product sa mga states na ito. Okay, so first we define kung ano ba yung inner product. Okay, sa vectors, ang inner product is the dot product. And the mathematical operation is precisely the same. Okay, so walang pagbabago. And if you're familiar with you're familiar with linear algebra, okay, then it's straightforward na multiplication lang ng row at saka ng column. Okay. So the computation of the inner product becomes convenient and elegant with the Dirac notation. Okay, so kahapon, tinignan natin yung ket 0, bra 0, inner product ng bra 0, tsaka ket 1. Okay, so inner product ng bra 0, tsaka ket 1, nakita natin na ito ay 0. Okay, and we were able to derive that by simply using yung matrix representations ng bawat ano. Okay, then, so for example, 0, 0. Okay, so this will become, yung bra 0 is 1, 0, and then yung ket 0 is 1, 0. So row multiplied by column, and this will become 1. Okay, tapos yung 1, bra 1, and then 0, ket 0 is just 0, 1, okay, row matrix na 0, 1, and column matrix na 1, 0, and this is equal to 0. And yung ket bra 1 and ket 1 is just 0, 1, then 0, 1, and this is equal to 1. Okay, so of course, this follows yung tinatawag na orthonormality condition. Okay, ang sinasabi lang natin dito is that yung ket 0 at saka ket 1 ay orthonormal sa isa't isa. So when you take the inner product of orthonormal states, you get 0. So inner product ng 0 and 1, tsaka ng 1, 0, you get 0. Pero when you get the inner product of tawag dito, the same states like what you did here, you get 1. Okay. Okay, so now let's try yung bra psi and then ket psi. So dinerive na natin before yung bra psi, okay, which is this one, diba? Bra psi. So we can generalize this. Let's say psi 1 tsaka psi 2. So we get alpha 1 star, okay, bra 0 plus beta 1 star, bra 1 multiplied by alpha ket 0, alpha 2 ket 0 plus beta 2 ket 1. Okay, and unahin muna natin ito. So ito muna. Okay, what we get there is alpha 1 star, alpha 2, and then ket bra 0 ket 0. Okay, plus. Tapos ito naman. Ito. Tsaka yan. Okay, so ganitong gawin natin para mas clear yung operations. And later, sisend ko naman yung notes sa inyo. So, alpha 1 star, alpha 2, ket 0, 0. Okay, para yung orange corresponds to yung kung alin dalawang products yung multiply ko. Okay. And then ito naman yung red na color. Okay, so corresponds to yung multiplication ng first term dun sa first parenthesis and the second term dun sa second parenthesis. Okay, so this is now alpha 1 star, beta 2, and then ket bra 0, and then ket 1. Okay, tapos, mamit tayo na ibang kulay. So, ito naman ang dalawang multiply natin. So, plus, okay, and beta 1 star, alpha 2, bra 1, 0, bra 1, ket 0. Okay, plus, and then ito naman dalawa. Let's choose ito. Yan. Okay, so, oops. Beta 1 star, beta 2, and then bra 1, ket. Okay, so alam natin na ito ay 1, ito ay 0, di ba? Mula dito sa mga numbers na ito. Ito ay 0 at ito ay 1. So we end up with alpha 1 star, alpha 2 plus beta 1 star, beta 2. Okay. Okay, so any questions so far? Any questions? Wala. I hope na clear sa inyo yun. Okay, so just to make sure na clear sa inyo, let's consider one example. Okay, so halimbawa ito. What is the probability of measuring 0 if the state of a qubit is 1 square root of 1/2 ket 0 plus square root of 1/2 ket 1? Okay, probability of measuring 0 or ket 0. Okay. So paano natin makukuha yung probability na yan? Okay, so tawag dito. Alam natin na from definition, so yung psi, okay, is 1 over square root of 2 ket 0 plus 1 over square root of 2 ket 1. Okay, alam natin na ito from definition, di ba? Itong amplitude na ito. Okay, yung amplitude na yan, okay, if you take yung square niyan, so 1 over squared, okay, that will give us yung probability. Okay? So yung probability is 1/2. Okay? At pag ito naman, okay, ay in-square natin. Okay, so 1/square root of 2 squared, that will give us yung probability na makakuha ka ng ket 1. Okay, so the probability of measuring 0 is 1/2. Okay, and the probability of measuring 1 is 1/2. Okay, but there's a more convincing siguro na method para makita na yung natin yung probabilities na yan. So what we do is to use the inner product. Now, ang probability is defined as okay, so let's say alpha and then psi, and then kunin natin yung modulus squared niya. So this is the probability, okay, of measuring. Okay, this is the probability of measuring, okay, yung state na alpha, okay, with respect to yung wave function na psi. Okay, so if we apply yung definition na yan, we can get yung probability of getting 0 dun sa wave function. Okay, if we apply yung definition. Okay, so yung 0 applied to psi is, okay, ang ket 0, di ba, is wait. Ket 0. So ganitong gawin natin. So 0 and then psi. Okay. Tapos star and then 0 and then psi. Okay. Bakit ako naglagay ng star? Kasi i-define natin yan before na asan na ba yun? Okay, ito. Pag modulus squared, okay, alpha star times alpha. So ganun din ginawa natin dito. Okay. So 0 alpha bra 0 ket psi. Okay. Times bra 0 ket psi. Pero yun dun sa una merong star. Okay, so ang gagawin natin dito ngayon is actually in general, this is not just psi, but this is also yung dagger. Okay, so pag ganyan, babalik na rin natin, di ba? So magiging psi 0, kasi ito 0, psi. Okay, kasi pag i-apply natin yung dagger, ito magiging bra, at ito magiging ket, right? Now, yung psi is 1/square root of 2. Okay. Tapos, bra 0 plus bra 1, and then ket 0. Yan yung first term. Okay. Times yung second term, which is bra 0. Okay. Times 1/square root of 2. And then ket 0 plus ket 1. Okay. Now, we know what happens if we multiply these two. Okay. Equal lang yan sa 1. At pag multiply natin itong dalawa, equal yan sa 0. Okay. Yun yung na-derive na natin kanina. Okay. So, this is 1 and this is 0. And the same thing happens here. If we multiply ket 0, bra 0 by ket 0, then we get 1. And if you multiply bra 0 by ket 1, get 0. So we end up with, okay, so meron tayong dalawang 1/square root of 2. So that gives us 1/2. Tapos, etong ket 0, that's just 1. So yung first term is 1. And then, dito naman, dito naman sa pangalawa, we have ket 0, that's 1. And then ket 0, bra 0, ket 1, that's 0. So we also get 1. So this is 1/2. So now we have derived in a more mathematical sense yung probability of measuring ket 0. Okay, so you can derive in a similar way yung probability na makuha yung ket 1. Okay, so simply by applying itong equation na ito. Okay, so this you also get you also get 1/2 for that. So probability of measuring 1, okay, in this state is 1/2. Okay. Okay. Any questions? Kailan kayo? Nasusundan niyo pa? Okay, so now, yun yung inner products at yun yung probabilities. Okay, so now let's go to yung mga quantum gates. Okay, so tawag dito, quantum gates can exist, okay, depending on kung ilang qubits yung pinag-uusapan. So, syempre, yung simplest na quantum gate, simplest set of quantum gates ay yung 1 qubit na quantum gate. So, let's begin with that. 1 qubit quantum gates. Okay, so, first of all, ang isang property ng quantum gates, okay, is that they are matrices. Okay, and these matrices must be unitary. Must be unitary. So, ano ibig sabihin ng unitary? So, if you have a matrix U, kunin mo yung dagger niyan, and then multiply it by the matrix U, is the same as yung matrix U multiplied by yung dagger ng matrix U. Okay? At equal lahat yan sa identity matrix. Okay, so if you recall, okay, this is called the adjoint of U. Okay, and now this is called the identity matrix. So, identity matrix is a matrix na kung saan all elements are 0 except for the diagonal elements which have value of 1. Okay, so an example of an identity matrix is 1, 0, 0, 1 for a 2 by 2 matrix, or for a 3 by 3. Okay, you have 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Okay, so lahat ng diagonal elements ay 1, okay, pero the rest of the elements ay 0. So yan ang identity matrix. Okay. And it turns out na ang unang-unang gate, okay, is also an identity gate, okay, which we symbolized as I. Okay, so ito yung unang gate, 1, 0, 0, 1 for one qubit quantum gate. Now, pag 1 qubit quantum gate, it's always a 2 by 2 matrix. Okay. Then another gate is called an X gate. or this is called a NOT gate. Okay, so ang symbol nito is X equals, so again, it's a 2 by 2 matrix, pero dito yung off diagonal elements yung 1. At tawag dito, well, not off diagonal elements, but yung diagonal opposite direction, yun yung 1. Okay, now bakit siya tinawag na NOT gate? Ang ginagawa nitong NOT gate is ini-invert niya yung state. Okay, so for example, if we apply the NOT gate to state 0, to get 0, okay, so what we're essentially doing is we're multiplying this matrix, okay, to the state 0. Okay, and what we will get is, diba, 0, okay, 0 times 1, 1 times 0, that's 0, and then 1 times 1, tapos plus 0 times 0, that's 1. So ano ba tong state na to? This is actually get 1. So ang ginawa, ang NOT gate converts yung get 0 to get 1. So finiflip niya yung state. Similarly, we can get yung application. Pag in-apply natin yung X gate or yung NOT gate sa 1, we expect that we get yung, okay, we expect that we get yung ket 0. So makita natin dyan, 0, 0, plus 1, 1, so that's 1. Then 1 times 0, plus 0 times 1, then that's 0. So and this is essentially ket 0. Okay, so again, finlip, okay, nung NOT gate yung state from 1 to 0. So yun yung ginagawa ng NOT gate. Okay, one of the more common gates na ginagamit and more useful, okay, gates ay yung tinatawag na Hadamard. Okay, Hadamard gate. Okay, at yung Hadamard gate is written as 1 over square root of 2, 1, 1, 1, negative 1. Okay, so Hadamard gates are quite useful, okay, in many applications. So marami ka makikita mga Hadamard gates in almost all quantum circuits. Sa entanglement, okay, gagamitin din natin yung Hadamard gate. Okay, so how does this work? Well, ang ginagawa ng Hadamard gate is kino-convert niya from yung basis state na 0, okay, to a new basis state. Okay, which are called plus or Hadamard basis, okay, na dinescribe natin kahapon. So let's see how this works. So if we apply yung Hadamard na gate sa ket 0, okay, so we have 1 over square root of 2, 1, 1, 1, negative 1. And then your ket 0 is this. So what do we have? Okay, so we get, of course, dyan yung 1 over square root of 2. Okay, so ang unang makukuha natin is 1, okay, 1 times 1 is tawag dito 1 plus 1 times 0 is 0. So 1. Okay, and then ayusin ko lang. Okay, so 1. And then ito naman 1 times 1 is tama, 1 times 1 is 1, and then negative 1 times 0 is 0. So this is also 1. Okay, and we can separate this into two states. Okay. So 1 over 1, 0 plus 1 over square root of 2 times 0, 1. Pwede natin gawin yan, di ba? Kasi tulad ng ginawa natin kahapon, yung alpha and beta, in-add natin. Pero this time, we're separating yung 1 at saka yung dalawang 1 na ito into two states. We're doing that because now we know that this is ket 0, state 0, and this is ket 1. So we have 1 over square root of 2 ket 0 plus 1 over square root of 2 times ket 1. Now, ito is called a plus state. This is one of the Hadamard states, and this is a new basis state. What about Hadamard applied to ket 1? So we have 1 over square root of 2, 1, 1, 1, negative 1, okay, and then 0, 1. So what do we get? 1 over square root of 2, tapos 1 times 0, 0. 1 times 1 is 1. So we have 1. Then 1 times 0 is 0 plus negative 1 times 1 is negative 1. Okay, and then we separate it again. 1 over square root of 2, 1, 0 minus 1 over square root of 2, 0, 1. Okay, so I hope naintindihan nyo kung bakit nilabas ko yung minus sign. Kasi this will allow me to express this as ket 0 and ito naman ay ket 1. So 1 over square root of 2, ket 0 minus ket 1. And this is now called the, this is another Hadamard state, which is ket minus. So ito ang ginagawa ng Hadamard. Okay, you're converting from this old basis states na 0 and 1 to these new basis states na plus, minus. Now, if we apply naman yung Hadamard dun sa basis states na bago. So we have, ano yan? 1 over square root of 2, 1, 1, 1, negative 1. Okay, and then yung plus state. Okay, remember na yung plus state is this one din, di ba? Okay, so we just apply that there, 1 over square root of 2, 1, 1. Okay, so what do we get naman? So this will become okay, so 1 half. Okay, so 1, okay, 1 times 1 plus 1 times 1, that's 2. Okay. And then tapos 1 times 1 tapos plus negative 1 times 1, that's 0. Okay, tapos ito naman, hindi tama to. Okay, so what do we have? So we have 1, 0. Pero ano ba ang 1, 0? Ang 1, 0 is ket 0. So, makikita natin na invertible pala yung Hadamard. So, if we apply Hadamard to ket 0, we get ket plus. And if we apply yung Hadamard to ket plus, then we go back to ket 0. So, nai-invert okay, ang ginagawa ng Hadamard is in-invert niya rin pabalik dun sa ket 0, sa original na state. Similarly, if we apply yung Hadamard sa ket minus, so we have 1 over square root of 2, 1, 1, 1, negative 1. Okay, and then 1 over square root of 2 tapos 1, 1. So we get 1 times 1. So first may 1 half dito. 1 times 1 okay, is, ang tawag dito? Sorry, minus to. So minus dapat dito. 1 times 1, okay, 1 times 1 is 1, plus 1 times negative 1 is 0. And then 1 times 1 is 1. Okay, plus negative 1 times negative 1 is 2. Okay, so we get 0, 1. Then we have ket 1. Okay, so again, if you apply Hadamard to state 1, you get state minus. And if you apply Hadamard further, dito state minus, you get back ket 1. So nag-i-invert yung Hadamard state back to its original state. Okay. Then we also have yung Z-gate. Okay, so ang Z-gate is written as 1, 0, 0, negative 1. Okay, so if we apply yung Z-gate sa ket 0, then we have 1, 0, 0, negative 1. Okay, 1, 0. Okay, and what do we get here? So 1 times 1 plus 0 is just 1. And then 0 times 1 times negative 1 times 0, that's 0. So this is just 0. Okay, so walang ginagawang Z gate sa ket 0. Tignan natin sa ket 1. Okay, so 1, and 1, 0, 0, negative 1, and then 0, 1. So what do we get? 1 times 0 is 0, plus 0 times 1 is 0. So 0. 0 times 0 is 0, negative 1 times 1 is 1. So this is negative 1. Or this is negative negative ng 0, 1 or negative ng ket 1. Okay, so pag 1, okay, you still get ket 1 pero i-invert mo yung sign. Pero pag 0, you only get 0. So you only have a change of sign if anong tawag dito? If you get the negative, if the state is 1. Okay. Okay, so banggitin ko lang yung ibang states. So we also have yung Y gate. Okay, so Y is equal to 0. And then ito naman ay imaginary. Okay, you also have yung S gate. Okay, so S is equal to 1, 0, 0 exponential I pi over 2. Okay, so may ganyan na ngayon. May ganyan na pag S gate. And then pag T gate, you have T is equal to 1, 0, then 0 exponential I pi over 4. So these are all useful gates. Makikita natin na if we square itong T squared, we get S. And then if we square yung S, okay, we get yung Z gate. Okay. So, and also, yung set of gates X, Y, and Z are called poly gates. Okay, so they're called polygates kasi if you remove yung square 1 over square root of 2, you end up with yung poly matrices. Okay, so if you're familiar with quantum physics, then you know what poly matrices are. Okay, pero if you're not, then it's totally fine. Now, how do we represent yung gates? The representation of gates. Okay, in quantum circuits, yung X gates are represented. X gate is represented as simple box na may X. Okay. Yung Y gate is represented again as simple box na may Y. And then yung Z gate is represented as Z. Okay. So Hadamard gate is represented as a simple box with H. And then yung S gate is represented as S. And then yung T gate is represented as T. Okay. So, but not all gates are represented in this manner. Okay. So, yan lang muna ang introduce ko sa inyo ng mga gates for now. Okay. Bukas, ang titignan natin ay yung concept ng block sphere. Okay. At makikita natin kung bakit tinawag to na X, Y, tsaka Z gates. And then tignan din natin yung 2-qubit states. Okay? Tapos saka tayo tumingin ng tawag dito, quantum circuits. Okay? Now, I'm going to use the rest of the time, so mga 9 minutes, okay, to introduce to you a software. Okay? Kasi gusto ko lang introduce sa inyo yung software para pwede, kasi kailangan nyo maggumawa ng account eh. Okay, so I'm going to stop sharing. Okay, so stop share. Okay, tapos introduce ko yung software sa inyo. Okay, so oops. So ang gagawin nyo lang, ito naman yung i-share ko. Desktop. Okay, so ang gagawin nyo lang is pumunta kayo sa Qiskit, type nyo lang Qiskit, IBM. Yan, ibm.com. Okay. 'Yan. 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 ' Okay, so ito yung ilalagay ko dito. Oops, sa chat. Okay, yeah. So nilagay ko sa chat. Okay, pwede nyo i-open ngayon kung gusto nyo, pero you still have to, you still have to create an account. Okay, so since meron na akong account, pwede kong i-open itong tawag dito. Um, Now, for some reason, hindi nag-work yung UP email address. So you have to use your tawag dito. You have to use your personal account to be able to access this. Okay, but it's straightforward naman yung pag log in. Yeah, okay. So, anong makikita niyo dito? Once you're in here, you'll see this. Tingnan natin kung pwede kong yeah. Nakikita niyo ba? Nakikita ninyo. Let me just check, okay? Kung anong nakikita ninyo. Okay, so you see this, itong mga sa ilalim. So you have documentation, tutorials, okay, tapos, okay, ano ko pupunta sa, yeah. Then you have this composer, okay, dito. Okay, tapos may announcements, and then, yun, yung apat lang na yun. So what you're interested in is itong composer. Okay, so once you log in, you go to composer, and then you go to start building. Okay, and then you see all of these stuffs. Okay, so first, makikita nyo rito yung mga quantum gates. So yun yung mga operations, okay, na available. Okay. So of course, familiar kayo sa Hadamard gate. Then you have yung T gate, S gate, Z. Then ang X is actually this one. This is a NOT gate. Okay, and yung Y is somewhere here. Ito yung Y. Okay. Okay, but dito, you have to take a measurement. Okay, so ito yung tawag dito, yung tab para or yung operation icon, okay, to take a measurement. Okay, since we only use a single qubit pa lang, so we can remove these for now. Okay, and since we also need just one classical state. Okay, so isa lang muna yung gagamitin natin. So, ang initial value ng state na to is 0. Okay, and makikita niyo yan dito sa graph na ito. So this is state 0. Okay, so it's 100% nandun sa state 0 siya. Now, ang gagawin ko is i-apply ko tong Hadamard gate. Okay, and what do I get? I get, okay, 50% probability na 0 siya and 50% probability na 1 siya. Okay, and that's what we get kanina, di ba? When we apply the Hadamard gate to ket 0, we get 1 over square root of 2 ket 0 plus 1 over square root of 2 ket 1, which is actually yung ket plus na state, di ba? Yung new basis states. So 1 over square root of 2, pag in-square nyo yun, that's 1/2. Okay, so we have 50% probability na mapunta kayo sa ket 0 at 50% probability na mapunta kayo sa ket 1. Okay, yun yung ginagawa dito. Of course, you have to take a measurement, so you apply this, okay, but you'll end up with the same. We end up with the same kasi Hadamard gate lang naman yung in-apply natin. Okay, but yan, so tignan niyo to at the very least mag-open kayo ng account para bukas when we are discussing these things. Okay, makakasunod kayo dun sa sa discussions. Okay. Now there's also dito sa left panel, there's also this equivalent na Python code. Okay. So this is embedded dito sa IBM Quantum na platform. Okay, and ang ginagawa nito is it registers only a single qubit. So if we add a qubit, so makikita nyo na nag-register siya ng bago. Okay. Okay, and if we add more, so nag-register siya ng bago. Ayan, so nakalagay dito kung ilang qubits yung quantum bits yung ilalagay. And if we add more classical bits, okay, so makikita nyo rin dito yung kung ilan yung i-register niya na classical bits. So yeah, this is quantum registry and this is classical registry. Okay, and ito naman, this means na ina-apply niya yung Hadamard on the first qubit. So Hadamard on the first qubit. So Hadamard on the first qubit. Then we're measuring Hadamard, measuring the first qubit. So yun yung nakikita natin dito. Tanggalin ko na to para hindi confusing. Okay, so we're measuring the first qubit, and what we get is registered to the single classical registry. Okay. Okay. So yun yung ginagawa ng Python code. You can also do this in Python, but you have to install yung Qiskit. Okay? And wala na tayong time for that tomorrow kasi medyo short lang yung ating time. Okay? And itong sphere na to, okay, nandito sa baba, okay, is called a yan. It's called a block sphere. At yan yung una natin i-discuss bukas para maintindihan niyo kung ano nangyayari dito sa block sphere. Okay? Okay, so yan. Again, this video will be available mamaya-mayang konti dun sa MindLab na Facebook page. And I'm also going to include yung link dito sa Qiskit na platform. Okay? So, if you don't have any more questions, then thank you for coming, and then I hope to see you again tomorrow para sa last part ng course. At I hope mas maging exciting sa inyo kasi itong quantum platform, ito talaga yung pinaka-useful para sa inyo. Okay? So, thank you.
Thank you, sir. Bye
Thank
po.
you. Sige, bye-bye.